Okay, okay, no issue. No issue, no issue. Okay.
Okay, sir.
So in the previous class, we did started a new chapter in the batch. That is acid, bases, and salts. All right. And in this chapter, there are various topics, various concepts which you guys would be learning about. Okay. Like you would be learning about acids. Is my screen stuck?
Yes, sir. Sir, I had a question.
Mm-hmm.
The notes you sent it, we're supposed to write with all of them, right?
See the notes that I share now. You can you can take help of that note in order to prepare your own notes. Okay, now that is kind of a reference material for you guys. You don't have to copy the whole thing like you would be having your school notes also. Getting it now? So I would be recommending you to make your own notes also. So the PPTs that are being provided to you guys now, so you can take it as a reference material only. Okay. What has happened over here? There's some issue over here, I think. My screen has got stuck. Is that the case? Can you guys see my screen moving or not?
Sir, your camera is off.
Yes, sir, we can see.
My camera is just hold on for a minute. Okay, anyways. So in the chapter we are going to be learning about various concepts. Like we'd be learning about what are acids, what are their properties, namely their physical and chemical properties. Then you'd be learning about what are the different types of acids and what are their uses. Huh? So you'd be having naturally occurring acids. Some of the acids are prepared in the laboratory. Huh? Then in the naturally occurring acids, different edible fruits, different edible items will contain some acids in them. Getting it, guys? So you'd be learning about that. Then we would be later on learning about
Study about one type of acid, sir, that is present in sour.
Yeah, right. In the previous class, we did learn about some of the types of acids. Okay. Then we would be learning about bases. What are bases and what are their physical and chemical properties? You'd be learning about that. Then we'd be learning about their uses. Then you'd be learning about what is neutralization reaction, what are the neutral substances, huh? And like generally we know that acids are substances that are sour in taste. Acids would be substances that would be sour in taste, and bases are substances that are bitter in taste. But acids and bases, they can be highly strong. They can be very strong also. They can be strong also. Getting it now? They can be so strong that they can damage the tissues of the human body, tissues of the animals. So thereby, it's not possible for us to go on to taste every acid. In order to check whether a given substance is acid or not, it is usually not always safe to taste it. So for that purpose, we'll be using certain indicators in order to check whether a given substance is acid or not. Like just to give you a small idea about this, like there are some chemical substances, like we have chemical substances like this. We have litmus paper. We take help of litmus paper in order to check whether a given substance is acid or not. Or we'd be taking help of some
Sir,
in
sir,
yes.
when the formula is acidic, it changes to blue.
Now we'd be learning about that. We'd be learning about it. I'm just giving a recap right now. Okay, now just giving a recap, particularly for those who were absent. Okay. So then we'd be having several examples like China rose petal would be used in order to determine whether a given substance is acidic or basic in nature. Okay, now. So that is something we should be learning in the chapter. Getting it, everyone? Fatima, Zunaira, Suleiman. Yeah. Then
Yes, sir.
later on, you'd be learning about what are different types of indicators. Like there are some natural indicators and there are some synthetic indicators that are prepared in the laboratory. Getting it now? So there will be two types of indicators also, which we will be learning in detail. Okay. Then later on, we would also be learning about. Just hold on for a minute. Yeah, sorry, there was some connection issue from the other device. Yeah, someone had a question. Someone has raised their hand. Yes,
Sir,
Priyanka. Hmm.
what's the name of the chapter?
Yeah, the name of the chapter is Acid, Bases, and Salts.
Sir,
Okay,
are
na?
we supposed to write this?
Sir, but
Yeah, actually, yes, Priyanka.
we finished this.
Yeah, for you and for Abu Bakr, this chapter was finished. But for you guys, this will be kind of a revision class. You will get to revise the concepts, revisit the concepts that you guys have learned in the chapter. Okay, na?
Okay, sir.
Hmm.
Sir, are we
Yeah, for
supposed to write
yeah,
this?
you guys are supposed to write all this. Okay, na? So do one thing. Do one thing now. Since like some of you were absent in the previous class, so I won't be. It won't be able to possible for me to give another 5 or 10 minutes to write this down. So I will do one thing after the class. Remind me at the end of the class. I will share the screenshot, or if you guys can take this screenshot, please take it.
Okay, sir. We'll take screenshot.
Okay, all of you done.
Yes, sir.
Also, we'd be learning about acid rain. Then we'd be learning about what is pH scale. Huh? Then we will be looking at the waste that comes out of the factory, how it is harmful for the nature. What is the nature of the waste coming out of the factory? Is it too acidic? Is it too basic? Huh? So if it is too acidic, what impact it will have on environment? Huh? Like the factory waste, that the waste that comes out of the factory, either it will be going into a water body, or either it will be dumped into open land, so it will cause pollution. Right now, so we'll be learning about that in detail. Furthermore, we also see that after repetitive use of fertilizers on soil, let's say a farmer for so many years have been using fertilizers on his soil without caring for the health of the soil, so in that case the soil might become highly acidic in nature. Right now, if a farmer continues to use fertilizers on soil, uh, without adding organic waste, without adding manure, so ultimately that soil turns infertile because it becomes too acidic because of continuous addition of fertilizers. So how soil has to be treated, so that thing also we'll be learning in the class. Okay, now so I've given a brief idea. In the previous chapter, we did learn about acids. So we learned that acids are basically those substances that have a sour taste and are corrosive in nature. They are corrosive in nature. For example, if it were to fall on the surface of our skin, or if it were to fall on a piece of marble or on a rusted iron, it will start to eat the surface. It will start to damage the surface. Getting it? So it will start to corrode the surface. Huh? Like, have you observed this? Like, mm, if you happen to visit Taj Mahal in Agra, so you will see that the marbles of the Taj Mahal now is a kind of facing a problem called as marble cancer. Now you will ask me that what is this marble cancer? Yeah, a very unique term. Yes, Fatima, Aman, Priyanka. Yes, Zunaira. So
Yes, sir.
marble cancer is basically a phenomenon where the surface of the marbles are being eaten away due to acids. What acids? Who is pouring the acid on the marble of Taj Mahal? It is basically the acid rain. Now there are so many factories around Taj Mahal. Several factories are there. Although those factories now have been relocated to another area, but earlier there were several factories around Taj Mahal, right? And those factory, the chimneys of the factory releases toxic gases into the atmosphere right now, and those gases combines with the rainwater to form acid rain. So due to acids, the surface of the marbles are being eaten away, it is being corroded, and it loses its luster, it loses its shine, and thereby gets a dull appearance, turns pale yellow in color, turns pale yellow in color. Getting it, everyone, what I'm trying to say?
Sir, could I go drink water?
Yes.
Could I go drink water?
Repeat again.
Could I go drink water?
Yeah, sure, sure. Okay. So they are said to be corrosive in nature. Right now, got this so far? These 2 points. How they are sour in taste, like you have drink lemon juice, like lemons or oranges, any citrus fruits, huh? Or like for example you have curd or vinegar, all of them have a sour taste because they contain acid in them. Getting it now? Also you would have observed, like if you were to pour some lemon juice on your hand, like it will give you a tingling sensation, right? It gives a tingling sensation now. Why? Because it kind of, we know that acids are corrosive in nature. That's why it gives a tingling sensation. Got this so far? Furthermore, another important property of acid is now, like when acid is dissolved with water, when acids are dissolved in water, or basically when you have a liquid acid. Okay, now see, acids can be turned into solid state also. They can be turned into a powdered form also. But whenever water is added into a dry acid, or when a acid is in its liquid state, so it gives out hydrogen ion. It gives out hydrogen ions. That is another interesting thing about the acids. Say what I'm trying to say. We have several examples of acids. Like you have hydrochloric acid, that is HCl. You have sulfuric acid, that is H2SO4. You have HNO3, nitric acid, HNO3. What all of them have in common? They all have hydrogen in common now. H, H here stands for hydrogen. Getting it, all of you? Yes, Aman, Priyanka, Suleiman, Zunaida, Fatima. Getting it, everyone? So all the acids have hydrogen atoms in them. Getting it? That is another property of acids. You can understand it in this manner. Some of the common example of acids are as follows. You have hydrochloric acid, lactic acid, citric acid, or sulfuric acid. These are the some common acids. Okay. Furthermore, in order to check whether a given substance is acidic in nature or it isn't acidic in nature, so for that purpose, we have got an indicator. We'll be learning about that later in detail. Okay, now, so just to give you a small idea about this, basically, do tell me, like in this seventh standard, all of you would have learned about would have learned about lichens, right? First of all of you turn your cameras on in the class. Where did you guys went? Are you guys even sitting there in your study room, or how do I know that you guys are paying attention in the class? Yes, Aman. Yes, Suleiman. Yeah. So what I'm saying that all of you know about lichens now. What are
Yes, sir.
lichens? They are
Yes.
symbiotic association between alga and
Sir,
fungi.
and fungi. Sir, where alga provides food and sir,
Hmm.
fungi provide shelter.
Good. Right. Which one of them is photosynthetic in nature?
Sir, algae. Sir,
Algae.
because it contains chlorophyll
It
and sir,
contains
then
chlorophyll.
it performs the process of photosynthesis and provides
Hmm.
all the food to the
Good. Good.
fungi. And sir, in return, it gives it
Hmm.
shelter.
Good. So I suppose all of you would be aware of this thing also. Usually, this lichens would be found to be living in such a place now that would be very much polluted. Just give me a moment. Let me show an image of this to you guys. This is what I'm talking about. See, this yellow patches that you see over here. The first one is has grown on a wall. The another one is grown on a dead stem, right? So this lichens are, by the way, found to be growing in such an area which is highly polluted. Okay, now so it's an indicator of pollution also. Okay. Anyways, getting back to the topic. Now, this using this lichens, what we do, we'd be taking it from we'd be taking some lichens. It will be first of all dried. Okay, now it is dried, and then later on we make papers out of it. What do we do? Using this lichens, we make litmus paper.
Papers out of it.
Right now, litmus papers are made. Getting it now? Okay. Now this litmus paper is dyed into two different colors. This is originally this is purple in color. Okay, now the natural color of litmus paper is purple, but it is later on dyed into two colors, namely red and blue.
Didn't.
As yeah, as you can see over here, the blue litmus paper and the red litmus paper. Okay. So say in this beaker, you have acids. All of you pay attention here. This is the most important thing about acids. This, you have acid in this glass beaker. And as you are dipping the red litmus paper, you observe the color changes to red. Right? Getting it, everyone? So that is the way to check whether a given substance is acidic or not. If you dip blue litmus paper into it, it turns red in color. That is the check. That is the indicator. That is the acid indicator. That is how it works. Okay. Now, although this topic lichens, we'll be learning about that later on also. So far, is this clear to everyone or not? Now, furthermore, in the previous class, we were also learning about types of acids. Okay, no? So on the basis of occurrence, there are two types of acids. Namely, they are naturally occurring acids, which are also called as organic acids, or the one that is made by us in the laboratory. They are man-made acids or also called as inorganic acids. Okay. So naturally occurring acids are like, for example, citric acid. It will be found in oranges, right? Lactic acid will be found in the curd, right now. By the way, you guys tell me which bacteria is responsible for turning milk into curd? Which bacteria converts milk into curd?
Is it kind?
Mm-hmm.
No, sir.
Lactic acid.
Lacto?
Lactic acid.
No. I'm asking about the bacteria now.
Oh,
Sir, which?
Which bacteria converts milk into curd? It's the lactobacillus bacteria. Lactobacillus, okay? There's a bacteria by this name of lactobacillus. It converts the milk
Sir,
into...
lactic acid, sir, we also call it.
No, lactic acid is a different thing. Okay, now due to when milk is converted into curd, now so then it contains lactic acid. Okay, now these are two different things. This is a living organism. This is an acid now. Completely different things. So far it's clear. Then you have vinegar, which we also call as sirka, used in the kitchen. It is added into different different food items. That is vinegar. In Urdu, we also call it as sirka. So I suppose some of you would be aware of this. So that contains acetic acid. Or the ant or the bee sting, why it gives such a burning sensation, such a stinging sensation? Why it is so painful? Because it contains acid. The bite of ant or bee contains an acid called as formic acid. Tamarind, that is imili, it contains an acid called as tartaric acid. The green leafy
Sir, all of
spinach.
them are sour acids.
Yeah, usually all of them would be sour. Usually all of them, like the oranges or curd, vinegar, all of them have a sour taste now. Right? The tamarind, spinach also somewhat has got a sour taste. If you have noticed, would have eaten spinach, that will have a slight sour taste. So that contains oxalic acid. Is that much clear to everyone so far or not? Right? Now then we have certain man-made acids also, right now. So we have several man-made acids. We're talking about them. Man-made acids or basically inorganic acids, right now. By the way, before we discuss about that, one important thing to be noted is that usually the natural acids are weaker. Their strength is, they are weaker in terms of their strength. Okay, na? Like if you try to dissolve some metals in them, huh? So the metals will not dissolve in them very easily. Getting it, guys? It will not be that much corrosive in nature. Like if oxalic acids will fall on our skin, it will not burn the skin. It will not be that much corrosive in nature. That is one thing. So they are weaker in nature. Then talking about man-made acids or inorganic acids. So we have several examples. Like for example, we have sulfuric acids or nitric acids. Getting it? These are some of the man-made acids. Okay. So sulfuric acids or nitric acids are man-made acids. Is that much clear so far?
But we are not supposed to write this, right?
This one,
Yeah.
yeah. See, usually, no, there's two ways. One is that you guys can go on to write everything that we discuss in the class, or you can do one thing. The first thing is that you can parallelly note down everything as I'm speaking in the class. Or other thing is that right after the class, you can make the notes. Okay, that is something which you can do. Okay. Or by the way, for the first three chapters, did you guys got the PPT of first three chapters or not? Nutrition plants, nutrition animals, and heat. Yes, Fatima, Aman, Priyanka, Suleiman. I have shared the PPT of first three chapters. Did you guys got it?
Yes, sir.
Got it? No? Okay. Like that, I will be sharing the PPT of other chapters also. Okay, now it is being readied. It is now ready. I will be sharing it very soon. Zunaira, you will also be getting the PPTs. Okay. Hmm. So those are some of the man-made or inorganic acids. Then we have some of the acids, like for example, hydrochloric acid. Hydrochloric acid. So that is can be man-made also, and it is present in our body also. You guys know that in nutrition in animals, you will have learned that the inner lining of your stomach secretes this hydrochloric acid now. Getting it, everyone? The hydrochloric acid is secreted by our body also. Is that clear to everyone? Secreted by inner lining of the stomach. And you know that this acid is usually very strong. This hydrochloric acid that is secreted by the inner lining of your stomach, it is usually very strong. Okay, now it has a pH value around 4 to 5, which is very strong. We'll be learning about pH value in the later classes. Right, so that is the two types of acid. These are the two types of acids based on occurrence. If anyone has any questions in this, please let me know. Yes. Okay, na? Furthermore, here I did basically explain in the previous class, particularly those who were present would be able to understand, would be able to recall this concept. So what I said that whenever water is added into acid, or whenever water is present in an acid, meaning that an acid is not in a dry state but in a liquid state. Okay. So then what happens? Say for example, we have this hydrochloric acid. HCl is the formula of hydrochloric acid. In short, hydrochloric acid is written as HCl. Getting it? So when you are adding hydrochloric acids into water, so thereby what is happening? Look at the next image. Then what happens? The hydrochloric acid gives out hydrogen ions and chlorine ions. What are these? These are basically charged particles. Okay, now just know this much that these are the charged particles. Basically, charged particles are called as ions. You should be just knowing this much that charged particles are called as ions. Okay, now. So when a acid is in the liquid state, so that acid basically breaks into usually hydrogen ions and whatever other component like chlorine is found in this, so chlorine ions will also be there. If it were to be a sulfuric acid like this one, so this will break into hydrogen ions and sulfate ions. Getting it? This thing I have explained because earlier I did told you guys that acids upon dissolving with water gives hydrogen ions. Acids upon dissolving with water gives hydrogen ions. So that I explained with this.
Is it possible, sir? Is it compulsory that all the acids mix with water?
Yeah, all the acids are soluble in water. All the acids usually.
Sir, then oil?
Oil is not an acid, no?
Sir, but it contains.
See, some oil contains acids. Some of the oil, some of the oil can contain acids, but necessarily not all of them. Okay, na?
But sir, why do they not like
Because
mix?
yeah, because of their difference in the density now.
Yes, sir, I wait. But sir, it is only containing acid, and acids are soluble.
See, for
But that
example,
also, sir, we have to keep in mind, sir.
yeah, we have to keep that in mind also. But for anything to be miscible into each other, for any two liquids to mix into each other, the difference in the density should not be that much. If there's a significant amount of difference in their density, like why does oil float above water? Huh? Because oil is less dense as compared to water now. Thereby, oil floats above the water.
But sir, oil contains some acids, sir, and
Hmm.
acids are soluble with water, sir. That's what I'm asking, sir.
See, it contains a negligible amount of acid. A very negligible amount of acid is found in it. Getting it? What I'm trying to say. Like for example, say for example, you were to take some acid. Let us say oil. Say for example, if you were to take coconut oil, for example. So say if there's a 1 gram, 100 gram of coconut oil, so there will be only 0. Somewhere around 378 0.378 gram of acid in it. So is this such a big number? No. So thereby it will not make any difference. Getting it, Aman?
Yes, sir.
Okay, so that is the thing. So hope it is clear to everyone.
Yes, sir, it is.
Now let us learn about the physical properties of acids. Remember, I said that we'd be learning about physical and chemical properties, right? So physical properties, in fact, some of them we have discussed earlier. Right, a physical property which you can basically observe, which you can feel, right? So acids have the following physical property, like they are sour in taste. Okay, they are sour in taste. Furthermore, they will be turning blue litmus paper blue litmus paper to red. Remember, which we learned moments ago, blue litmus paper is turned into red color. That is another physical property of acid. Getting it now? Furthermore, acids would be having a pH value less than 7. Now you would be confused, like what is this pH value now? Huh? See, using a indicator now, like using this litmus paper, you can only tell whether a given substance is acid or a base. Can you guys tell how much stronger it is, or is it a weak acid, or is it a strong acid? That you won't be able to say now. That you won't be able to decide. So for that purpose, later on in the chapter, we'd be learning about pH scale. pH scale is a scale where where we get to where we see the it has a range from 0 to 14. Okay, it has a range from 0 to 14, and this is 0 to 14, and the middle you have 7. So if any acids have a value between 0 to 7, if it is a having, if any substance, I mean to say, has a value between 0 to 7, like it has a pH of 0 or 2, 3, 4, 5, 6. Okay, now up to 6, right? So then it will be a acid. This will be an acid. Or if any substance has a pH value between 7 and 14, right now, like 8, 9, 10, 11, 12, or 13. So then it will be considered as a basic substance. It will be a base. Okay, now this topic we'll be revisiting, so don't worry that much about this. Okay. So pH scale is a kind of a scale to measure the strength of a given substance, strength of a acid or base. So if an acid has a pH value closer to 0, if it has a pH value like 0, 1, 2, 3, so in that case it will be considered as a very strong acid. Right now it will be considered as a strong acid. And if it has a pH value like 4, 5, or 6, it will be considered a weak acid. Getting this, guys, what I'm trying to say? All of you know? Okay. So that is one thing. So acids would be having, by the way, acids would be having a pH value less than 7. Right now they would be having pH value like 6, 5, 4, 3, 2, 1, or 0. Getting it? That is one thing. So that is another physical property of acids, that they have pH value less than 7. Is that point clear to everyone? Okay. Furthermore, there's another physical property of acid. Uh, that they, by the way, this much only, I think, yeah, only this much. They have sour taste, they have a pH value less than 7, they'd be turning blue litmus paper into red, that much. Now let us talk about the chemical properties of acids. Okay, now. So chemical properties of acids are that they would be reacting with a number of substances. Like when acids would be reacting with metals now, when acids reacts with any metal, not any metal, they would be reacting with only certain kind of metals, by the way. So upon reaction, the products that will be formed will be a salt plus hydrogen gas will be released. Do you guys getting? This is a chemical property. Why? Because a chemical reaction is happening here. In a chemical reaction, a new product is formed right now. Like burning of a paper is a chemical reaction, because earlier you had a paper, now you have the ashes of the paper. Those are two completely different products. Their properties are completely different from each other. So here also, when an acid would be reacting with metal, it will go under chemical reaction now, in which new substances are formed. You guys tell me, the products on the left hand side, the acid and metal, are the same with same to the salt and hydrogen gas? Are the same as the product in the right hand side? Yes, Zunairo,
No, no, sir.
right? So therefore, this is one of the chemical property of acids, that it will be reacting with metal to give out salt and release hydrogen gas. Getting this so far? Another property is that acids will be reacting with base. Acids will react with base. But remember, we have to discuss about base and we have to discuss about neutralization reaction later on in the chapter. So acids and base, both of them have completely opposite properties. Acids are sour in taste while bases are bitter in taste. Getting it? So, but when these two will be reacting with each other, they will be canceling out each other's property. Both of them would be neutralized. The product that you will be obtaining will be a salt that will neither be sour in taste, neither will be bitter. Salt has a different taste now as compared to an acid or base. It is neither salty, I mean to say, neither sour nor bitter in taste. Along with salt, water is also formed. And in fact, this reaction you guys would be learning about in detail. Okay, now when we would be learning about the about neutralization reaction, now there you have to revisit this concept. Okay, there you have to revisit this concept. Like look over here, where an acid or base would be reacting, a salt and water will be formed. Okay, now a salt and water will be formed in such a reaction? Hope you guys are getting it so far.
Yes.
Okay, that is one thing. Furthermore, um acids would be no. As I was saying that acids would be reacting with metal. Let us take one such example. Say that we have taken magnesium. We are learning the first one. Say we have taken magnesium. Magnesium is a metal, okay, and we are trying to react it with some acid. Okay, now let us say we are trying to react it with acid. Let us say we have taken hydrochloric acid. Okay, let us see what happens in this case. Okay, now by the way, you guys have a look at this image over here. In this, we have taken some pieces of magnesium. Okay, now in this, we have taken some pieces of magnesium. In short, magnesium is written as Mg, by the way, and we are dissolving it into hydrochloric acid. Hydrochloric acid. So upon dissolving acid and this magnesium, can you guys observe some bubbles in this?
Yes.
Do you notice bubbles?
Yes.
So you know what are those bubbles? Those bubbles are of hydrogen gas. Remember what I said, that acids upon reacting with metal gives salt and hydrogen gas. So those bubbles formed in this is that of hydrogen gas. Getting it now? Okay.
Yes.
Also, as I told you, a salt will be formed right now. So the salt that will be formed, just let me drag it over here, by the way. So the salt that will be formed will be magnesium chloride plus hydrogen gas is released. Plus hydrogen gas is released. So is this much clear to everyone so far or not? Yes, Aman, what did you understood from this? Yes. Zunaira?
Sir, I still learned that, sir.
Hmm.
Sir, there are some different, sir, if we combine some different acids and base, sir, we get salt. Sir, like there are other equations, or sir,
Hmm.
if we add, sir, other acids, base, or sir, like metal.
Hmm.
So, sir, there are a lot of equations for this. And sir, I also learned that sir, hydrogen, hydrofluoric, magnesium, and these are also some sir main components sir in this chapter. And sir, we also sir there are also different kinds of acids.
Okay, see what I just said now. So you have taken any acid like hydrochloric acid. We were learning about this moments ago, right? I gave an example of this acid. This is the same acid that is released in your stomach also. So hydrochloric acid. See, I have taken a test tube. This is called as test tube. All of you know this, right? In a test tube, I have first of all put some magnesium metal, some granules, some smaller particles of magnesium metal has been put into this, and I have put hydrochloric acid into this. When I shake it now, when it will be dissolved now, so I observe that a gas was formed. Bubbles were coming out of it. Right now, that bubbles were basically the hydrogen gas. You guys ever observe this? Like when the cold drinks, when you shake the cold drink, so many bubbles are formed in it now. When a cold drink is shaken, so lots of bubbles are formed. What are those bubbles? Basically,
Sir, the air.
those are carbon dioxide gas. Now, the different kind of cold drinks that you drink, those are basically carbonated drinks. that contains carbon dioxide into it. Okay, now so when you shake them, carbon dioxide gas starts to form bubbles and starts to come out. In the same manner, the bubbles that you see in this, that is hydrogen gas. Okay, no. So acids, they can
Sir,
react with
then
metal.
how are hydrogen gas and carbon dioxide different from each other? Sir, because when we shake them, both have the same result.
See, if it were to be any other gas, no, in that case also bubbles will be formed. Based on a formation of bubble, you can't say that how are they similar or dissimilar. Bubble, basically any gas will give out bubbles. Okay, no. Even if it is oxygen gas, it will be giving bubbles. You guys tell me, like when water is boiled, do you not observe bubbles?
Yes, sir. Yes,
Bubbles
sir.
forming in boiling water. What are those bubbles?
Sir, it's the carbon. No, sir. It's the oxygen escaping.
Yeah, it's the oxygen, no? Right? It's the dissolved oxygen in the water that it starts to form bubbles and come out. Getting it, Zunaira, Aman, Priyanka,
Yes,
Fatima?
sir. And sir, when we take a steam, sir,
Yes.
if
Hmm.
you know about steam, sir, when people are
Mm-hmm.
sick, sir, yes, sir.
I
So
know.
when you take a steam, and sir, the water is boiling, sir, it
Hmm.
also makes
Hmm.
bubbles, and like, sir, the oxygen is escaping. And sir, also, sir, when we
Mm-hmm.
put our face above it, sir, our face
Hmm.
also gets full watery. And
Mm-hmm.
sometimes, sir, when we bath with hot water, sir,
Mm-hmm.
some oxygen also escapes, sir. If you can see it on
Hmm.
our body, sir,
Hmm.
the
Good,
bubble.
good. Right. Okay. Very good. By the way, talking about some of other important properties, some of particularly chemical properties. So acids now they can conduct electricity also. They can conduct electricity. So they are good conductors of electricity. Getting it, guys,
Sir,
what I'm trying to say? Yes?
what is the good conductor of electricity?
Acids are good conductors of electricity. Okay.
Oh, okay, sir.
So far, what are the properties we have learned? Let me just sum it up for you guys.
The chemical properties of acids and the physical properties of acids.
Hmm. So first we learned that acids reacts with metal to give salt and hydrogen gas. That is something which we learned. Next, we learned that acids react with bases to give salt
The
and
salt and water.
water. Very good. Okay, that is something which we learned so far. Few other things which we have to learn is that acids are conductors of electricity. Getting it now? So
Sir, but sir,
acids.
I have sir heard somewhere, sir,
Mm-hmm.
electrical wires and like,
Hmm.
sir, sir, in big places like some big buildings, sir, there is a
Mhm.
basement, and sir,
Hmm.
all the power collectors are there.
All the power connectors are there in the basement of the building.
So, like all the switches for the
Yeah,
electricity.
yeah, it is there. So how
But
is
sir,
it
I
related
have
to acid?
heard somewhere, sir, that
Yeah.
somewhat of electric wires are made up of acids.
No, usually the electric wires, no, they are basically of solid material.
Sir,
Okay, now acid is not used. Usually copper or aluminum wires would be used in that.
no, sir, I'm not talking about wires, sir, the
Hmm.
materials.
The material, no,
Yes, sir.
that is by the way not true. Okay, no, the electrical power cable conductors in their manufacture acids are not used. Okay, no, they are
Okay, sir.
mainly made up of electrical cables or power circuits. Would be basically the metal that would be used in them would be either copper or aluminum because these are the good conductors and more safer. Okay, talking about some of the other properties. As I said, they are capable of conducting electricity, so they are good conductors. Say for example, if I were to take a battery, okay, now if I were to take a battery, connect a bulb to this, and if
It
I
will
were
glow.
to, yeah, if I were to
Add
dip,
sir, wires.
mhm, if I were to dip the wires into this acidic solution, say that this is
Then
hydrochloric
sir, it
acid.
will also light up.
Yeah, it will glow. This will glow. I have connected a battery also, by the way. Note this thing down. Okay, na?
Sir, then if we have some such good
Mhm.
source of electricity, sir, then why do people,
Mhm. Why are we people?
sir, like for electricity, sir, why are
Huh.
people, sir, I don't remember exactly, sir, I don't know why, but sir, solar panel, yes, sir. Sir, why are people using solar
Okay,
panels?
okay.
Sir, we
See,
can
see,
also use acids
see.
in such a manner.
There's a difference between source of power and a conducting material. Acid is not a source of electric power. It's basically a conductor. Just like copper wire is a conductor, it will allow electricity to pass through it. In the same manner, acid is basically here acting as a conductor. Zunaira, you understand now what is a conductor? Fatima, Priyanka, Aman. So
Yes,
it
sir.
is merely acting as a conductor. It allows the charges to flow through it. It is not acting as a power source. So there isn't. So
Conductors are, sir,
talking about solar power in this context, it is irrelevant. Solar powers of work on basically semiconductors are used in solar power panels. Okay, and that's a different thing. Getting it? So it will allow the electric current to pass through it, thereby the bulb will glow. So that is another property of acids. Hope that is clear. Okay.
sir, sir, we
Hmm.
use insulators to cover electrical wires. So what
Yeah.
if we use conductors instead of that?
So then, if you were to touch it, we will be getting electrocuted. Okay, we will be getting electric shock. Getting it?
Okay.
Okay. So that is one thing. By the way, just now I remember one more property of acid is that acids can be existing in all three states. Acids
Solid liquid gas.
hmm, can be
Sir,
solid, yes, liquid,
sir, I think, sir,
and gases.
I don't know, sir, if it's right or correct or wrong. Sir, but
Hmm.
in periodic table, sir, in
Hmm.
periodic table, sir, are there elements of acids? Some.
That is not the way how we look at it. When we look at the periodic tables, now there you have all the elements arranged in periods and groups. When you would be looking at the periodic table, all the different elements are mentioned over here. So it wouldn't be appropriate to say that acids or bases those are listed over there right now. Basically, we have more than 118 elements found in the nature, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. All these are
The
different
platinum.
elements found in the nature. Yeah, getting it now. So all these elements can most many of them can combine with each other to form several new substances. Like for example, hydrogen and oxygen, both of them are elements, right? Zunaira, Priyanka, Aman, Fatima.
Yes,
Hydrogen and
sir.
oxygen, these are elements found in the nature, and both of them combine with each other to form.
Sir,
Yes,
hydrogen.
I'm saying both of these can combine together to form what? It can
Sir,
form water,
acids.
no? Water is H2O, no?
Oh, sir, you asked about H2O.
Mm-hmm.
Sir, I thought it
So
was hydrogen, sir.
no, hydrogen and oxygen combines to form water. So all the elements in the periodic table can combine to form water. Anyway, that's a different thing. Getting it since you asked it, so thereby it was important to clear it out. Coming
In the
back to the
periodic
topic,
table, sir, is there any other element for water, sir, like H2O?
no, apart from hydrogen and oxygen, you can't form water using any other element other than hydrogen and oxygen. Okay, no?
Okay.
Hmm. So hope this property is clear to all of you. Okay. Furthermore, there are certain safety measures that we have to take care of. Like we know that strong acids and some concentrated acids are very much corrosive in nature, and they can cause severe burns even if we were to have a very short contact with them. Like particularly there are certain kind of acids now that would be very strong, and even if you were to hold it for just
Like,
a
sir,
short
normal
period of
acid,
time,
sir.
it will be, yeah.
So, like, sir, so there are
Hmm.
also acid present in, sir, cold drinks, no?
Yeah, but that is not a very strong acid, no.
Sir, yes,
I'm
sir, I
only
know.
talking about
But,
the
sir, if
strong
you
and
pour it on
concentrated
your
acid.
hand, sir, you
Mhm.
will feel some kind of, sir, sensation in your hand.
Yeah, but it will not give you a burning sensation. You will be getting a tingling sensation, but not a burning sensation. Okay, getting it. So say you are provided with a very strong acid. So
That's
say
why
you,
whenever sir we drink acid, and
hmm,
so that's why sir we feel like fizzy. Sir, when we burn.
yeah, that do happens. Okay, no. So say for example, if you happen to visit the chemistry lab in your school, so they would be having lots of strong acids. Okay, no. So if your teacher asks you to make that acid weak, say you are provided with we are provided with a very strong acid, and we have to make it weaker. Try to understand this. You're provided with, just 1 minute here, a
So,
strong
sir,
acid. Yes,
we put acid to water to make it weak.
exactly. Right now. So we are
Yeah.
trying to understand how it has to be made weaker, or basically, rather than calling it weaker, we say it to be dilute acid. Okay, na? So we have usually the inorganic acids, which we also call as mineral acids. Like for example, you have hydrochloric acid. Let us say hydrochloric acid. Say we have a sample of a very strong hydrochloric acid, and we have to make it weaker. Okay, na? So we have to basically dilute it. We have to dilute it. Try to understand the terminologies over here. By the way, this is a strong acid, or we also call it as concentrated acid. Now, let us first of all let me clarify the concept of concentrated and dilute acid. Normally, basically concentrated acid will have very less water in it. Okay, now concentrated acid will have very less water in it, while a dilute acid will have good amount of water in it. So thereby, concentrated acid will be stronger, dilute acid is weaker because of more amount of water in it, right? So if I want to convert a concentrated acid into a dilute, I need to add water into this. So what should be the method? So we should always add acid to water drop by drop, and using a glass stirrer, like using a glass rod, we should stir it. We should keep on mixing it. So that is the safe method. Also, you should wear all the
Sir,
safety. Yes.
so like will you give examples sir like dilute. So sir, like that sir we also have some different solutions sir like copper solution.
Copper solution.
Yes, sir, when it's dilute, sir, it's really weak. But sir, when we add water to it, sir, it is a
Mhm.
strong solution for them.
No, no, I'm not getting it. Like what you're trying to ask,
So like
Aman.
this copper sulfate solution, na?
No, no, this isn't copper sulfate solution. Nowhere it is
Sir,
written
I
that
know,
it's
sir.
a.
No, sir, I
No,
know,
no.
sir, you're talking about acids.
Yeah, I'm talking about acid, but copper sulfate solution is not yellow in color. It's blue in color, by the way. Okay, no.
Yes, sir, yes, sir, I've
Copper
done some
sulfate.
experiment.
Okay, you have done experiment on this. Yeah, that's good.
Yes, sir.
Hmm.
Sir,
Like you
I've
would.
done it for electrostatic energy, sir.
Oh, that's good.
Sir, we
Okay.
took a wire and sir, in a beaker, sir, we put like a
Mm-hmm.
metal scale or something like that, and sir, a spatula. And sir,
Mm-hmm.
we connected the spatula and the metal scale, sir, with a battery. And sir, then
Mm-hmm.
we poured copper sulfate solution, sir, dilute
Mm-hmm.
in it. Sir, it changed the all of the color of both, sir, the spatula and
Mm-hmm.
the metal scale. And sir, oxygen was also released, sir, between that. Sir, also bubbles were
Good, good.
forming.
Mm-hmm. Very good. Okay, no. By the way, this copper sulfate, no, that you are quoting, it's an salt, by the way. Okay, no, that's a salt actually.
Sir, can we
Cop.
drink it?
No, it wouldn't be safe. Okay, no, it won't
Okay,
be
sir.
safe. By the way, it's not edible. What are you
Because it
saying?
contains
Mhm,
salt, sir, that's why I asked.
mhm. You see, salt is also conducting material. That's why in your experiment setup, you would have used that. Okay, no. Okay. Talk, going back to the topic, what I was trying to explain, that we have to take all the safety precautions, like the gloves or safety specs have to be. We have to wear the safety specs, so that even if there were to be some splash, if you accidentally splash the acids, right, or accidentally, what you do, you forgot to add acid to water. Rather than doing that, you added water to acids, right? In that case, that will be a very exothermic reaction. That will be very, it will be a explosion. Okay, now it will be
Sir,
very
but why?
explosive in reaction.
But sir,
Uh,
the thing is only same, sir. Here,
the
if we
thing,
add, sir,
Mhm.
water to acid or sir, acid to water, sir, sir, thing only will be same, sir.
Mm. See, the reason is now this acid is a highly concentrated acid, very strong acid. So when a very strong acid, when lots of water is being added into it a single time now, so
Sir, what
thereby
if we
it,
add, sir, into sir, weaker, sir, into weaker acids?
so in that case it will not be explosive reaction if it's a weaker acid. Like lemon juice, you add any amount of water in it, it will not be explosive reaction. But in this case, we have a concentrated acid. If you were to add lots of water into it at the same time, right now, so then in that case lots of heat will be given off, and it will be a kind of explosion. In fact, accidentally I did this when I was in, I have to believe, when I was of your age in 7th standard. So what I did now, I knew that in fact I knew that we have to add acid into water, just but out of curiosity what I did now, in order to find out, let's see what happens, so just I poured lots of water into it. And so the glass in which that acid was, that glass basically broke. Okay, now, by the way, don't try to do this at home. Okay, so that is one.
Sir, I can't hear your voice. Sir, I can't hear your voice.
Assalamu alaikum, sir.
Yes, walaikum salam. Halima, how are you?
I'm